Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve Leetcode question number 680. Valid palindrome 2. Given a string is written true if the string can be palindrome after deleting at most one character from it. So you want to return true if we can say a string is a palindrome after deleting at most one character. So what is meant by at most one character? We can take 1 or 0. It means we can delete one character or we don't want to delete any characters. Okay, let us see some examples. See here. So this is the first example. Whether yes is palindrome. Yes, it is palindrome. So I can return true. Okay. First of all, we want to know what is my palindrome. So just listen. A B A. Just read from here. A B A. Again, read from here. A B A. Both are same. So it is a palindrome. Okay. If we reverse a word and we can check it, the reversed word and the original word should be equal. Then we can say it's a palindrome. Clear? No. See the second example. A B C A. Whether it's a palindrome? No. But if I delete, see carefully, if I delete the C, it will be palindrome. This is one case. Again, take the same, and if I delete this P, I'll get again a palindrome. Fine. So this is also valid palindrome. This is also valid palindrome. If we get any one possibility, I can say it is a palindrome. See here, here also one deletion, here also only one deletion. We can do at most how many deletion? One deletion. So it may be 0 or it may be 1. So it will be true. Fine. Again, A, B, C. To make this as a valid palindrome, if I take this A, whether it is a valid palindrome? No. Okay. If I take this P, it's a valid palindrome? No. If I take the C, whether it's a valid palindrome? No. Whether ABC is a valid palindrome? No. Then I can say false because I deleted one character. Then also there is no match for the palindrome. If I delete 0 characters, then also there is no match for the palindrome. Then I can say it is false. Fine. So what is the approach here? Just watch this examples. By using this example, I can say if a given word is a palindrome, then just plainly return true, right? Okay. Again, what is observation number 2? If the given word is not a palindrome, then go and check whether if we delete this A, whether it's a palindrome. No. Whether if we delete this B, whether it's a palindrome. Yes. Whether we delete the C is a palindrome. Yes. When we are getting yes, then we can return what? True. Here also we get yes, right? So here also we can return it is as true. So this is my first approach. Okay. We're just going to one character and checking whether if we take the remaining characters. Just see here. If this is a character, I will take this character and I will take the remaining character. Whether it is a palindrome? No. Again, I'll take this B. This B. Whether it's a palindrome? Yes, it's a palindrome. So return true. So this is what the approach. Fine. So this is the what? Brute force approach. So brute force approach. What is the time complexity for it? I can say the time complexity is, just observe carefully. We are just traversing the string one time, and for each characters I want to traverse another time to all strings to check whether it is palindrome. Yes, so I can say it is over n square. And then what is the space complexity? It is over 1. So this is for the brute force approach. Now how to optimize it? How to optimize it? Just observe carefully whether we want to go and check after deleting 1111 characters. No, we just can do, we know at most one time. First of all, let us check whether it is a palindrome. If it is a palindrome, just return true. But in this case we can do by checking the palindrome from the last and the first. See here, I will check whether this A and this A are equal. Whether this A and this A are equal. Yes, it is equal. So I will go to the next point here. Whether this B and C are equal. No, no. Then I can do, my answer can be like, if I delete the C, or else I can delete this B. Okay. So now delete this B and then check for the remaining characters first. Then if it is false, then delete the C and check for the remaining characters. Understand? Let us take another example. A, B, C, maybe another A, B, A. Fine. So this is my string. Let's assume. First of all, I am checking this A and this A. They both are same. Okay, fine. Then move to the next. B and B. Yes, they both are same. Okay. But let us take, okay. Now go for the C and A. Whether they are same? No. I can either remove this A or I can remove this C to form a palindrome. If I remove the C, I form a palindrome, right? So I can return the true. Again, we can see another example. See here, AC, BB, A. Okay. For this example, see here, my pointer is here and here. Whether this A and this A are same? Yes, they are same. Now, this C and this B are same? No. So what should I do? I can do in two ways. Like, let me write two times. I can do in two ways. Already the pointer is on C. I can move this pointer here, just deleting this B. Or else I can move this C pointer one step ahead. Right? Initially the pointer is at C. I can move the C pointer one step ahead by deleting this C. Now you understand, we didn't delete that C or B, just we moved the pointer. So this method is called greedy. We only want to find whether we can do this or not. We don't want to modify the string. Okay, that's the rule of this greedy. Okay, now from this I can return true. This is false, but by deleting the C, I get true. So I will return true. Fine. So this is my approach. So this is my approach number one. Again, we can also do this approach in recursion format, right? Let me write it. See here, initially the value is AC, VB, A. Okay. Initially, I want to traverse from 0 in this. Let me write here. It is 0, 1, it is 2, it is 3, it is 4. So I can traverse as 0 and 4. Initially, I want to check the 0 and 4. I am checking the 0 and 4, whether the 0th element and the 4th element is equal. Yes, they are equal. Then go to the further call. To this recursion call, I will call 1, comma 3. Just shrink. Now the pointers are at here and here. Now whether the C and B are equal? No, they are not equal. So we want to split into two calls. Okay. By splitting these two calls, I will take this as f of, let me function as f of 2 comma 3. This is one function call, and then f of another thing, what, 1 comma 2. I can take in two ways. Okay, if I take 2 comma 3, whether 2 and 3 are same? Yes, it is same. Again, go to the further call. In further call, I will take f of what? I will take this plus 1 and then this is minus 1. This is what I have done here, right? From here to here, I want to take 1 plus for the first pointer and 1 minus for the second pointer. So I have done here. Again, whether I can proceed? No. My right pointer came here and my my right pointer came to the second index and left pointer came to the third index, where left pointer is greater than right pointer. Okay, just stop here. That's the rule of the palindrome, right? Just stop here. I can return true because we have reached the palindromic state. So I will return true. It also return true because here it is OR condition. Whether it is correct or it is correct, it will return true. So it will return true. Again, this function also return true to it. So this is the recursion format. Let us take one more examples to understand what is this recursion approach states. See here. Here I will take for f of 0, 2 because it is 0, this is 1, this is 2, right? Now I will call for a first call whether this 0th element and the second element are equal. No. Then we want to divide into the two categories. What are those two categories? It is one thing is f of what 1 comma 2 and another thing is f of 0 comma 1. Now just check whether 1 and 2 are equal. No, they are not equal. So we have already faced what? Not equal condition. Here also we have faced not equal condition. Again we are facing not equal condition. So return false. So this will return what? False. Okay, this will return what? False. Okay, let me see here because it is OR condition. It returns false, but if it returns true, I will want to return true. But see here, unfortunately, it is 0 comma 1. 0 is A and 1 is B. Whether it is true? No, it is false. So it also return false. So false or false will be false. So this will return false to the calling statement. So my answer will be false. Understand? Now what is the time complexity for it? Time complexity will be O of n. But space complexity will be, there will be a recursion stack so that it will be O of n. But for that looping approach, my time complexity is what? It is O of n because we are traversing only one time, and then my space complexity is O of 1 because we haven't used any auxiliary space. Here we have using the recursion stack. Okay, let us see the code. See here, this is the code for the normal approach. N is equal to len of s. L comma r is equal to 0 comma n minus 1. I am setting the first pointer and last pointer to the first and last element while L is less than r if s of L is not equal to s of r. If there exists a condition where first the Lth element and rth element are not equal, I want to check for L comma r minus 1 and L plus 1 comma r. Yes, so I will just make a function call to the check function where I will pass those two indices and it will check whether the the elements between those two indices are palindrome. If it is any one of it is palindrome, I will return true. Yes, else I will return false. Again, I want to shrink by L plus 1 and R minus 1. Shrinking one by one. Okay. And then at last I will return true. Fine. So this is my first approach. Let's submit it. See here, this is my optimal approach number 1. Yes, it is submitted successfully. Now we can also see the recursion approach, but for this question, this non-recursion approach is the best. But still, we want to know how to make some recursion call and solve this problem, right? So see here, if start is greater than end, start is greater than or equal to end, I want to stop and return true because we have reached the midpoint or the left pointer is moved the ahead right pointer greater than right pointer, so that I want to stop that. If s of start is not equal to s of end, I will make if this is the condition, then I want to do what? I want to do start plus 1 comma end and start comma end minus 1. I have done here, right? I have told you. And then I will make the flag as false because the flag is initially true. The flag is initially true. It means there is no false condition before. That's why I am checking. If it is true, I will go and pass it as a false, so that it says that already I have checked, I have met the condition where start and end is not equal. Fine. Else I will return false. Why? Because now also it is not equal. But before that also it is not equal. That's why the flag is false, right? Then only this else condition will be satisfied. Now return recursion of start plus 1 comma end minus 1 comma flag. If this is not executed, then I will return what? I'll just string the pointer by start plus 1 and end minus 1 and I will send the flag value as it is. If it is false, just send false. If it is true, send true. Initially my recursion call will be what? Sorry, my function call will be what? Just 0 len of s minus 1 and then true. True as a flag because we didn't encounter any false condition or true condition, right? So initially it is true. Let me submit it. This is also the optimal approach, but still you have to use the this approach. Okay. Thank you.